Hello everyone. Now in this video we are going to see how to construct a hyperbola using one more special method. The method, before going to the method, you can see the question on the screen. Draw a hyperbola when the position of a point P on it means on the hyperbola. A point on hyperbola is 70 mm and 85 mm from the asymptotes. The asymptotes are perpendicular to each other. So this is all about the question. What they gave that to draw a hyperbola, and they gave the position of the point P from the asymptotes. First of all, let's see what this mean by asymptotes. You can see that this is the two branches of hyperbola. This is branch 1 and this is branch 2. When double cone is there, when we cut at with a section plane, you will get two branches of hyperbola. This is branch 1 and branch 2. We can, as of now, we can take only one branch. You can see, guys, this is the hyperbola. This is the hyperbola which is having the vertex here and its focus point is here. Always every hyperbola will consist of two asymptotes. You can see 1 and 2. This one 1 and 2. Every hyperbola will consist of two asymptotes. Now what they gave in the question, the position of point P on it is 70 mm and 85 mm from the asymptotes. So let's take, suppose if this is the point, let's take this is the point. This point is 70 mm from this one, 85 mm from this one. You can see that already the angle between these two asymptotes is greater than 90 degree, which are not perpendicular, greater than 90 degree. When the angle is greater than 90 degrees, it will be called as oblique asymptotes. Right now it is in oblique asymptotes because the angle between the two asymptotes is greater than 90 degrees. When the angle between the two asymptotes equals to 90 degree, then it will be called as orthogonal asymptotes. So now in the question they gave the asymptotes are perpendicular to each other, means equals to 90 degree. So that's why we are going to choose the method called orthogonal asymptotes method. In the next video we will see about the oblique asymptotes. Very good. So now we got a clarity. The position of a point P on it is 70 mm and 85 mm from the asymptotes. The asymptotes are perpendicular to each other. That's why we are going to use the orthogonal asymptotes method, and this method is also called as rectangular hyperbola. Keep it in mind, rectangular hyperbola. Okay, let's start the procedure. Done. So these are the steps to be followed to construct a hyperbola by orthogonal asymptotes, or it is called as rectangular hyperbola method. Okay, first draw asymptotes OA and OB perpendicular to each other. Done. Z enter, A enter. Done. Now let me take a line, switch on the ortho. By default it should be bilayer color. Okay, let me take okay, we'll give the text now itself. Dimension text 5 0. This one I am taking it as O, and this one I am taking it as A, and this one I am taking it as B. Finished. OA and OB. We did OA and OB. Draw CD parallel to and from OA with one of the given distances. Okay, with one of the given distances. In the question, the point P is 70 mm and 85 mm from the asymptotes. So that's why I am taking offset 70 mm from the asymptotes. Perfect. See, DLI, dimension linear, DST, dimension style. For every video I am making the dimension style modification just for your practice. That's why, not for wasting the time. It's all about to make you to remember the command dimension style. Shortcut is DST, enter, modify. Perfect. See, 70 mm from the asymptotes. Once again, I am taking offset O. Shortcut is O. 85 mm from the asymptotes. Done. 85. Let's take this one also. DLI, dimension linear. Perfect. See, perfectly we made it. As of now, not required. We'll delete this one. Just for your observation only I did it. Later we can give it. Done. Now, this is the position of the point. Let me mark here P type. It's already 2. I'll make it as a 4. Okay. So this is the position of the point P. Control C, Control V. Okay, good, perfect. Next one, draw. Okay, this one is CD, DT. It is in 560. This is C, D, and this one is E, F. Keep it in mind. OA, OB is asymptotes and parallel lines to the asymptotes. We made it, and this one I took it as a CD and this one as a EF. Okay, next one, mark points 1, 2, 3 along CD which need not be equidistant. So anywhere you can place any number of points you can place. Take a point PO. Instead of typing PO for every time, you can see guys, under the draw multiple points are there. There is no shortcut for this one. That's why I am going with the graphical user interface. Select this one. Okay, okay, okay. So randomly I chosen these points. Now let's give the name for numbering for these points. This is very much important. This is 1 and this is 2, this is 3 and this is 4, this is 5. Perfect. Done. See, mark point 1, 2, 3 along CD. Finished. Join O1, O2, O3 and extend them if necessary to meet the line EF. What I mean to say is that first let us join O1, O2, O3, O4, O5. Keep in mind that whenever we are drawing these lines, always all these lines which comes from O should meet or intersect the EF line. Keep it in mind, this vertical line. Whenever we are drawing all these lines, either it should cross or it should meet. Definitely these two things happen. So this one already crossed 3, 4, 5, satisfied. Whereas this line didn't cross or didn't meet this line. So that's why I am giving extend command EX. See guys, extend means perfectly it went and met there. This one EF. Now these three lines crossed EF and these two lines met EF. This thing should be happen. Very good. Now mark the intersection points of line O1, O2, O3 on EF as 1 dash, 2 dash, 3 dash. Okay. Now DT. This one I am taking it as 1 dash. This one I am taking it as 2 dash. Only on EF I said, right? 3 dash. O4 line 4 dash. This is why I give very small text not to confuse. See this line on EF it is intersecting 1, 2 dash, 3 dash, 4 dash, 5 dash. Perfect. Now after making this one, through 1, 2, 3 draw lines parallel to OB. Okay. Through 1, 2, 3 draw lines parallel to OB. What I am going to do? Okay, parallel to OB. Here I don't want to draw a big lines, that's why you can see guys. Okay, let me wait, small lines also we can do it. So these two lines and these two lines are parallel to OB only. Perfect. And now through 1 dash, 2 dash, 3 dash, draw lines parallel to OA. Through 1 dash, draw lines parallel to OA. You can ask me why you went this way. See, the purpose will come to know. Perfect. Okay, now trim. So I need to mark these points. That's why 1 dash should meet. That's why I am going with this one. Perfectly. See, you can see this one, 1 and 1 dash, 2 and 2 dash. Similarly, for 3 and 3 dash, I made it. Coming to 4 and 4 dash, I made it. Coming to 5 and 5 dash. See how nicely we made it. Perfectly 4 and 4 dash, perfectly 5 and 5 dash, perfectly 3 and 3 dash. So this is how one method to make these points. So just by drawing the horizontal lines and then vertical lines and trimming the unnecessary points, we can make the intersection points. So just if you don't, just one more method I am going to teach you, that will be simple and easier for this one. Whichever you wish, you can follow. I am giving both the things. Okay, instead of drawing vertical lines and horizontal lines, the main purpose we know, to get the intersection points. Already I activated the object snap tracking auto snap on. Now take a line, just meet it here, click it, sorry, click it here. Now 2, click it here, click it here. Now first let's go with 5. Perfect. Now let's go with 4. From outer side it will be easy for you. From 3, see how simply I made it because of object snap tracking. That's the use. One thing, you can draw the horizontal lines and then trim it and then you can get it. This is one method. 2 methods I taught you. Now the intersection points of vertical and horizontal lines from 1 dash should be marked as P1, P2, everything. So now I am going with dimension text. Okay, let me go with multi-text, empty, enter. P1. P1 is should be suffix. Let me take to 6. Okay, switch off the ortho. Select this one, CO, copy, enter, specify base point, 0.1, 0.2, 0.3, 0.4, 0.5. Nice. Now let me 0.2. Good. 0.3. 0.4. Cross mark. 0.5. Done. Successfully we marked all the points. That's what. Now it's time to draw a curve. Spline, SPL, enter, specify first point P1 to P2. Generally people will straight away will go to the P3. No, P1, P2, this point, because in the question itself they asked us a point on the curve means this is the one P, and then go to P3 and then go to P4, P5. Just switch off. Okay. Now press spacebar don't press escape button. Press spacebar or enter. See, perfectly we made it. Now this is the hyperbola what we require. So now give some color. I am taking 0.4 to display the line weight. LWD, enter. on, enter. See, we successfully got this hyperbola curve. The point P is so and so distances as per the question. Now finished. It's time to draw a tangent and normal. Mark a point R on the hyperbola at any point. Okay. Now let's take a point here. It will be very big one. I don't want to go here. PO point. Let me take here. Control C, Control V. Capital R. So now at this point I need to draw a tangent and normal. So I marked R point. Okay, through point R, draw a line RS parallel to OA, meets at OB. So through point R, I need to draw a line which is perpendicular to OB, and parallel to OA, which meets here. So this is Control C, Control V. This point is S. Point R, point S. Successfully finished. Mark a point T on OB such that OS equals to ST. You can see first let's find out the OS distance is 89. Now on the same line with the same distance I need to mark a point here with 89 distance. That point will be the T. So what I am going to do, take a PO, specify a point from here, just move this one and then 89. Now you can see that DAL. If you observe carefully, exactly OS equals to ST. Let us copy this one. Control C, Control V. This point is tangent. OS equals to ST. Perfect. Now what to do? Join TR and extend it to T dash. That is the T dash is the required tangent. So now take a line R in the same direction, means switch off the ortho. Yes, you can see guys. Yes, this is the one. Select these two and apply some color and apply some line weight. 0.35 is sufficient. This is the T. Control C, Control V. T dash. Perfectly we constructed the tangent. Now it's time to construct a normal. Rotate, select two lines, tangent, rotate, and this is the base point. Copy, rotation angle is 90. Actually it's a very big line, we don't want this much. Let us go with a small one. In the same direction, using the grip, get it back. Control C, Control V. N, Control V, N dash. Now we successfully drawn hyperbola with respect to the distances from the asymptotes, and the asymptotes are perpendicular to each other. That's it. We finished it. Now it's time to give the dimensions. Asymptotes 85 mm from this one, 70 mm from this one. DAN, dimension angular, to represent the angle between the asymptotes is 90 degrees. Perfect. Remaining everything is done. Hyperbola curve, tangent, and then normal. That's it, ma.